as we're beginning here, I do need us just to remember and go back to how we deal with proportions or proportional reasoning. Fairly straightforward when we have sort of some fraction is equivalent to some other fraction, something out of 10 is equivalent to 40 out of 50. How do we figure out what's the missing value here, the missing variable? There's sort of two main ways people will do.
Well, if you want, you can just put it into the calculator straight up as it is.
How would you put it in your calculator? Most calculators won't be able to.
0 over 10 equals 40 over 50.
But this isn't 0 over 10. It's something over 10. Something over 10.
You can literally just put over 10.
Am I able to write my trigonometry test in Mr. Wade's room? So yeah.
I'm gonna have those who missed it actually do it in the next part of this class. I'm gonna talk for about 10 minutes.
Okay.
Great idea, thank you though.
Okay, never mind, that doesn't work.
So there's sort of two main ways of attacking this. One of them is a pretty straightforward thing to put in your calculator, and some of you are probably used to doing the cross multiply divide whenever you see this. You'll take this variable and you'll go whatever's kind of with it. So in this case, 10 times 40 divided by 50. So we'd go x is equal to 10 times 40 over 50. That would be a kind of common way of attacking this. And you end up realizing that x is equal to 8 in this case. That's perfectly legit. That's a good way to do it. Can you take your AirPod, please? Thanks. So x should be equal to 8 here. That's true. The other way, when I look at this truthfully, I kind of think there is one way that's a little bit easier. It's like, okay, what does it take to get from 10 to 50? So if I was looking at this, honestly, with one this straightforward, I'd probably go, to get from 10 to 50 was times 5. And if that's the case with the denominators, it needs to be the case with the numerators too. So if it was times 5 for the denominators, I can go times 5 for the numerators, and I say what times 5 is 40, x is 8. Right, so you can do the cross multiply divide, or you can just say, okay, what happened to the bottom? The same thing needs to happen to the top. Right? Or similarly with this b, I could look and say, okay, to get from 3 to 15 was times 5. So similarly, to get from 12 to x needs to be times 5, x is 60. Right, that's kind of understanding that this is an equivalent fraction. The left side needs to equal to the relationship on the right side.
Hold up, let me check something.
And if you want to cross multiply divide this, if you want to do the proportion, it would be x is equal to 15 times 12 divided by 3. 15 times 12 over 3. And yes, you'll get 60 as the value. So kind of two ways of attacking this. One is cross multiply divide. One is just look for what the relationship from one to the other is. And you'll find on C, that may not be quite so straightforward. Like for me, I don't know exactly what it is 2056 divided by something equals 4. Maybe you know that, but I don't know exactly what that number is. It's probably like 500 something. 500 and 512, yeah, great, nice, 512. So it's divided by 512, but most of us probably didn't initially know that. But if that is the case, 512, and I guess you probably can recognize that 512 is one of those nice doubling numbers.
542?
Yeah, so what number divided by 512 gives you 3? And yeah, the number is 1,542. Nice one. Or if you're like, no, I like that cross multiply divide, and some of you will love that because you can just do it every time. You could have just gone x is equal to 2056 times 3 divided by 4, and right, that would give you that same 1,542. Okay, next. And in some ways, once you find something that works, feel free to just stick with it, right? That's great. So if you like the cross multiply divide, feel free to just stick with it. Because in a case like this, it's not quite so clear what 25 times something is 40, right? It's going to be like 1.6 or something like that. So that may not be quite as straightforward for you. So if you're like, okay, I like the cross multiply divide, I'm going to say x equals 25 times 200 divided by 40. That's fine. Yeah, good.
2,000?
It won't be 2,000 here.
No, 200,000.
The number's going to be 150.
What?
Oh, 125. Yeah, right. Times 5. Yeah, 125. Thanks. X is 125. Yeah, that's right.
Oh, that's where I messed up.
25 times 200 divided by 40. Yeah, 125. Now, one thing I didn't point out earlier that you may also notice. I've talked about the relationship between numerator, denominator. Like for example, the relationship between 12 and x, 3 and 15 up there. However, there is actually a similar thing that you could look at of what's the relationship within the fraction. Hey guys, this is, I suspect, quite helpful for most of us. This is one of those key skills of 20-3 that still many of us don't know. What I'm saying here is, in one like this, 3 over 12 equals 15 over x. I pointed out that 3 times 5 was 15, so 12 times 5 would be x. However, you also could have said, well, instead, what's the relationship between 3 and 12? Right? This is 4 times smaller. So similarly, the relationship from 15 to get to x also needs to be 4 times. And in this last one here, that may have been more helpful. Right? 25 to x is the same as 40 to 200. Well, 40 to 200 is times 5. 25 to x is times 5. So you can kind of look, how do 25 and 40 relate? Or you can ask, how do 40 and 200 relate? And then just sort of extrapolate that to the other one. Either way, you're going to absolutely 125. Or using the method Gabe's been using, we could have said x equals 25 times 200 over 40. Nice. Yeah, 125. Great. So, cross multiply divide, proportional reasoning, key skill from 10-3. I hope we're still able to use that. Now, similarly, what about proportional reasoning with shapes? Proportional reasoning with shapes. Well, I'll show you what I would kind of look at here. I would say the relationship between this side and this side needs to be the same as the relationship between this side and this side, which needs to be the same as the relationship from this side to this side, which also needs to be the same as the relationship between this side and this side. That's kind of hard. So what you might want to just do to check is, I would say, literally divide each of the left sides by the right side and see if you get the same fraction. So like, 27 over 36 needs to be the same value as 42 over 56, which needs to be the same, oh, sorry, not 50. Oh, I see. These are, I probably drew this wrong. It is actually the same value, so that's part of what I did, but it's misleading. That one and that one, that one, sorry. Which needs to be the same relationship as 60 to 80. So we just check. 27 over 36 equals 0.75. 60 divided by 80, 0.75. 42 divided by 56 equals 0.75. We see, oh yeah, the relationship was the same in each case. Are they similar? Yeah, yes. And why? The proportion is the same. Or we could say, like, dividing the small one by the big one gives you the same decimal in every case. So these are proportional. And the nice part about that is, if those are proportional, if we know that the Hot Wheels scale model and the picture of the actual car are proportional, if it's a scale model, well, we can say, okay, the relationship from this one over to this one needs to be the same as the length over the length. So I could say, okay, 0.86 over 55.04. That needs to be the same relationship as 2.94 over x. Some of you may have said, hey, wait, I went 0.86 over 2.94 equals 55.04 over x. That will work fine too. Because of the way we do this math, we end up with x equals 2.94 times 55.04 over 0.86. And it wouldn't have mattered whether it's 2.94 times 55.04 or reversed, right? The relationship stays the same. 55.04 divided by 0.86. 188.16 is the value of x. Yes, sorry. 188.16. I've taken this x and gone 2.94 times 55.04 divided by 0.86.
I think that 8.6 was 8.8.
Okay, we'll look at one more example here together, you guys. Wow. This is nice. You can tell I put one picture on top of an old one, but I obviously did not remove it quite right in this copy. So maybe we'll just redraw this. Building casts a 9.5 meter shadow. 9.5 meters. At the same time as a 1 meter tall woman casts a 1 meter shadow. Get rid of that. 1.5 meter woman casts a 1 meter shadow. Okay, good. Get rid of the rest of this junk. Good. I'm wondering what the height of this building is. So if I'm setting up this relationship, actually, why don't you take a second, see if you can set up this proportion. See if you can figure out what the height of the building is there. This would be a pretty soft math 10-3 problem in your proportional reasoning. In fact, if you're in my 10-3 class, and maybe yours, you may have actually done something like this, where you go inside and measure a shadow, steps, something like that, measure the building under the steps, and figure out the relationships. This is actually a very similar type of math to the way that they figured out how far the moon is from the Earth, the sun sphere, using it. If we know the relationship between the shadows, we can find the relationship between the height of the buildings. One of you may have noticed, I think you have one of them flipped there, Gabe.
Yeah, I tried it the other way. I didn't.
So if you're going, I suspect this would be what most people do. The height of the person over the shadow length is equal to the height of the building over the shadow length. Something like that? Height of person over shadow length is equal to height of building over shadow length. We're doing the big idea with the proportion, and this is kind of hard when you're doing dimensional analysis, is you're trying to keep sort of similars on the same side of the equation. What I mean in this is, like, here I have person. Here I have building. Here I have actual height. Here I have shadow length. Right? Recognizing that you kind of want it to be like the same thing with the same thing. It would have been perfectly fine, by the way, if we had instead said, okay, on the left I want shadow length or something like that. I want, 1 over 9.5. And over here I want building height, 1.5 over h. Right? As long as we're recognizing it's like similar one way, top and bottom, and then similar the other way, top, bottom. So it's like here I've kept the height of the building and the person together. I've kept the shadow length together. On the top, I've kept person together and building together. You kind of get what I'm trying to hit there? I get that that's a little confusing. Whereas here I was like, okay, this left side is person. This right side is building. So then the top is person height and building height. The bottom is length of the shadows. And keeping the categories on the same center. And that is the opposite of what you're doing with proportional, or with unit analysis. With unit analysis, you're trying to cancel out similar things. So it is a little tricky. All right, anyways, to solve this, height equals 9.5 times 1.5 over 1. Well, that's nice, because divide by 1 is pretty easy. Red one, can you get that? I think it's unlocked though. Gabe, what'd you get? 45. Nice, thanks.
Funny, I didn't really do it originally, and when I did it the other way, I went back to this one so I could do it.
Nice, yeah. Okay. So I told you I kind of just want to do the very introductory work for this unit. We're not going to go into lesson 1. This is all we're going to do today. I recognize that there are some of you that still need to get caught up on your missed exams, those kind of things, and I think this is a good time to do that. So why don't I pause this here.